Hi, in the last video we've been measuring the rotational speed of this fan with an oscilloscope, and in this video we're gonna do the same task with a Canique Ambience sensor, red in the background, and transmit the output of the measurement via 868 MHz to a Canique Pico Gateway in this case. And the gateway then will transmit the message to an MQTT server, and we're gonna read the MQTT output finally. To describe the setup, it's pretty simple. We've got a 12 volt lab power supply supplying up to 100 milliamp. VCC is connected to the fan directly, ground is connected to the fan directly, and ground between Canique Ambience and this fan is interconnected to each other. Okay, so basically we can start, but first I just want to show you the current output. This is the output of an MQTT sub command, so it's a subscription. And as you can see here, the sensor is transmitting every 30 seconds the temperature, the relative humidity, and the pulse counter count. If you look closely, you'll see the timestamp is in millisecond precision, and it's also precise up to the millisecond. It always reads the same millisecond count. That's the last 3 digits. And what we're gonna do here, I'm pressing enter so it's easier to read. What we're gonna do now is turn on the channel 2. We start spinning, and now there should be an RPM signal on the orange wire leading to the Canique Ambience, and we're having a look now here. Okay, the counter is at 548. We're gonna read some more readings, have a look at them to see how the count is interpreted, what the count should be. The counter that you read here is not the RPM itself, it's the pulse count. As we said in the last video, this fan is sending 2 pulses per rotation, so this means you have to divide this count by 2 to get the RPM. But there is another thing to note, or even 2 other things. One thing is, this count is a differential count. It's not the absolute count since startup of the sensor, as you can see. Otherwise, the counter would have to go up with every transmission, but as you can see, it stays almost equal. The reason is it transmits the count since the last transmission, since the last reading. So if you miss a count, you still get the count, the pulse count, from 30 seconds backwards up to now. So it's always a 30-second time window that you're looking at. This count, this 894, is the pulse count for the last 30 seconds. This is why you have to multiply it by 2 to get the pulse count for 60 seconds. So you'd have to multiply it by 2 to get the 60-second time window, and then divide it by 2 to get the RPM. So basically the division and the multiplication cancels each other off. So you can interpret this in this case as the RPM without doing any math. So this is you got an RPM of 890 and something, and this is pretty close to the RPM that the manufacturer for this fan itself states. It's stated with 900 RPM. And if we turn this off, just turn it off now, then the count will gradually decrease. It won't be 0 at the next reading because I turned it off in between 2 readings. So it will be somewhere between 0 and 900 in the next reading, and then it will be 0 because it's already turned off. Look at the next reading, we're gonna read 0 again. So this is basically how it's working. And in the next video we're gonna do a power measurement. We're gonna measure the current consumption and see what we are consuming while we are not transmitting data and not reading any sensor data, but with the pulse counter still working, still counting pulses. That's what's going to be next. Thank you.